good morning. Welcome to stream. My name is Dr. Rachel Tapman, and my stream is for anybody who cares about language technology and other people. And today, for those of you who are watching and not listening, you will notice that I do not have my camera on, and that is because I am tired. And I just didn't want to deal with it, and I didn't sleep great last night. So this is the first stream in a new series / sub-series of the coffee chats that we usually do on Thursday. And this one is specifically for research papers. And I've also done a little bit of change to my coffee as well, which I'm showing here. That's ko-fi.com/rctatman. And for the papers specifically, I'm going to be doing them as an annotated bibliography. And if you would like just those papers, that is a new tier that is available. If you only want the links for the coffee chat on Thursday, which is now just going to cover, news updates and stuff. Hey, Dino, that'll be a separate option, and then you can get all the links as well. And everyone who is already subscribing to links has been grandfathered into all the links, so nothing will change for any of my current supporters. All right, enough with the announcements. Let's get into, I also had kind of a joke, a joke tier. That is, if you want your name fancy in the credits. I don't expect anyone to get their name fancy in the credits. Good morning, Vidya Sagar. Welcome, welcome. Let's hop right in. So today we have 4 papers and an abstract. And the reason we're going to be talking about an abstract is because it is not published yet. And I'll talk about that when we get there. And most of these are enough in my area of expertise that I think will be fairly able to talk about them as a peer researcher. This first one actually isn't. So this first paper is Federated Learning and Indigenous Genomic Data Sovereignty, which is a Nature comment. Nature comments are, I think, they're like shorter. They're sort of like letters to the editor, but they are peer reviewed, I believe. I'm not super familiar with the format. I've never tried to publish there. Linguistics papers that get into Nature tend to be, I'm making a face that you can't see. Let's just say they have a mixed history on sort of the quality of work in the field of linguistics. And the paper is by Nima Boscarino, Reed A. Cartwright, Keolu Fox, and Crystal Sozi. Apologies for anyone whose name I might have said incorrectly. And I am not certainly not a federated learning expert. I sort of know about it. Certainly not an expert on Indigenous sovereignty, even though it's, something that I think is extremely important and a necessary part of decolonization. And also not an expert on genomic data, but I thought this sounded like a cool paper, so let's hop in. And it's also fairly short. We're probably not going to read the whole thing verbatim, but yeah. Yes, okay, so it has been peer reviewed. There's a little section here at the bottom by Nature Machine Intelligence. And I learned about this because the first author, Nima, is, I believe, a developer advocate at Hugging Face, which is an NLP startup. So we have some shared, what's the word I'm looking for? A shared social network. So it came up through that. All right, let's hop in. So the little, it's not really an abstract, but I guess masthead, the big text at the front says, Indigenous people are underrepresented in genomic data sets, which can lead to limited accuracy and utility of machine learning models in precision health. While open data sharing undermines rights of Indigenous communities to govern data decisions, federated learning may facilitate secure and community-consented data sharing. Kohaku says, I love the reading streams. Are they available on my YouTube channel? I can't find them. They are, actually. Let me pop you in the link to the reading list. But this is, for those of you who are just joining, the first one that we are doing on Tuesday. And this should be an ongoing thing, because I was doing paper reading and all of the news stuff together, and the streams were just getting too long. I was too tired by the end of it. I had a hard time focusing and doing all the things that I wanted to do, including talking, because my voice was always going out. So I've posted the link to the stream link to the live stream playlist. It's called Paper Reading, and I'll probably reorganize my channel a bit so it's a little easier to find. Yeah, no worries, Kohaku, you're very welcome. All right. So I think the big themes here. So precision health is, again, not an expert, but my understanding is that it is medical interventions and treatments that are specialized to an individual or a small group of individuals based on specific genomic stuff, markers. That's a word gene people say. Yeah, there have also been, to answer Gohaku's question on reading streams, there's also been some on various other channels. So I've done some on the Raza channel, and I've done a lot on the Kaggle channel, which may be where you're familiar from them. And I think those might have gone onto the same Twitch. I don't remember. It was years ago at this point, but those are other good places to look for them. But to do the sort of, getting back to the paper, to do the sort of precision health stuff, you require genetic data. And I'm assuming a large enough database of diverse enough genetic data that different subpopulations are well represented, so you can learn about genes. Perhaps you have noticed this is not, again, an area of my expertise. And the reason I thought this paper was particularly interesting and relevant to me as someone who's more interested in language technology, you may notice that genomics is not really language technology, but there are a lot of overlapping methods. And also this particular, problem of something that is, important to indigenous sovereignty is just as true with language data as it is with, genetic data, right? So obviously there's a lot of diversity, understatement, there's a lot of diversity amongst various indigenous groups in the world, but for a lot of them, things like the recorded voices of the dead requiring, specific care or not being able to be distributed or having it be distributed being extremely disrespectful is not uncommon, right? There are multiple cultures where that's a thing. So if they want to, right, work with linguists to work on preserving language data, while at the same time maintaining, sovereignty and privacy, and maybe even perhaps making sure that no one actually listens to the data files, perhaps this is a way that, this type of approach could be helpful as well. All right. Yes, so the basic idea that open data sharing is not an inherent good, I think, is also something that it's important that we come to terms with as a field in natural language processing, right? All language data is human data, all genomic well, that's not true. Lots of things have genomes. All human genomic data is human data. And, we can't just use the genomes of genetics researchers who are cool with it, and we can't just use the language data of language researchers who are cool with it and continue to use our current approaches in either of those fields. So that's why I thought this paper was particularly relevant to folks who are working in language technology, even though obviously, at least in my case, I am not a geneticist. So some background. I think I'm just going to hop right down to this issues and concerns with sharing of indigenous genomic data section. And keep in mind that I think a lot of this will also apply to language data. Artificial intelligence, AI. Yes, that is the way the acronym usually is. Sorry, I looked at that and I was like, that's backwards. Usually the acronym is in the other direction. It is not. I'm just being dyslexic this morning. I warned you, I'm tired. Machine learning, ML, and data science tools are continually shaping biomedical research, especially as related disciplines continue forward in the digital data revolution. But something about that phrasing feels like something somebody slightly outside the field would say. In 2021, the U.S. National Institute of Health announced 2 initiatives that center on AI and ML approaches, the Bridge to AI and Aim Ahead programs, which specifically address the lack of diversity in both research and data, which are directed at addressing health inequities while preserving data privacy. So this has been, you know, in the past, certainly in the U.S. context, and also the present, a pretty big issue in the United States. So partially it is that research is not done on all populations, you know, consistently. And when it is done, it's not always done in a respectful or ethical manner, right? So an example of a population that tends to be under-researched is women between the age, or I guess people who can become pregnant between the age of like menarche and menopause, because they could be pregnant during the study or become pregnant during the study span, and then their data might have to be thrown out. They may need to be removed from the sample. So often a lot of sampling procedures will just not include people in that bracket. Turns out there's actually a lot of people in that age bracket, and being able to be pregnant may have effects that interact with other, stuff that may interact with other medical stuff. On the other hand, research done on particularly Black folks here in the US has often been done without their consent. So a great example of this is cell cultures taken from Henrietta Lacks, who's a Black woman, were taken without her or her family's consent, and these cell culture strains continue to be used today in medical research, which her family is kind of not okay with. And another example would be, we talked recently on the channel, I don't know if you watched the chat with Chelsea Troy about the Tuskegee Valley experiments, where specifically Black men were allowed to die of syphilis and were just sort of watched by scientists as part of a research experiment, which is wildly unethical, and has, very much negatively impacted, obviously both, the people who were directly involved, but also the wider community and their willingness to trust researchers, which, you know what? Fair. Very fair. I get it. Yeah, anyway, so there's a long history of inequities. For those of you who are not clear, the 2 words there are inequities, unequal, and iniquities, evil deeds, I guess, in the history of health research in the US. And also, of course, there's, larger social determinants of health, which tend to affect marginalized people more gravely. And of course, this is also true of anything where we're collecting data, right? Again, I'm focused specifically here on the US context, but I'm sure you are all, more familiar with the context in your own countries, or, if you're from the US, also the US, and can think of, certain social groups which are going to be getting the dirty end of the stick. All right. Robbie says, women get pregnant, not people. I mean, many women can get pregnant. Many people who are not women also can get pregnant, and many women can't get pregnant. So it's not a super helpful distinction to use, right? It's what is relevant here is whether or not the person can get pregnant, not whether or not they're a woman. All right. Yes. So continuing on in this strand, sorry, that was a lot of background, but again, also very relevant to language data. The ethical components for these initiatives, however, are weighted heavily towards concepts such as open data access, which center on researchers' data access and utility, but not communities' interests. Although access to genomic data may facilitate research that addresses the genomic divide, open data access conflicts with indigenous data sovereignty, IDS, creating a pressing and timely dilemma. And again, I think this is very relevant for us in the NLP field right now, particularly with, large models being trained where the training data contains PII, personal identifying information, that can be leaked and is memorized by the model and can be, made to recite it. The open data movement supports the open sharing of data as a means to democratize data access for researchers. But Indigenous people and communities question whether this transfers too much data decision-making authority outside of Indigenous data governance structures. Unlike for other subsets of individuals who may be included in genomic research, the United Nations Declarations on the Right of Indigenous People, UNDRIP, whoa, what a horrible acronym, recognizes and respects the self-determination and self-governance of Indigenous peoples. This includes the right to, quote, maintain, control, protect, and develop their technologies, including human and genetic resources, which is exemplified by calls from global Indigenous peoples for the cessation of large-scale diversity genome projects in their communities. Also, again, just historical information there. Much of the research that was done on Indigenous communities, specifically historically around, before we knew about genetics, a lot of the sort of like skull measuring stuff was being done by people whose entire research program was to prove that white people were better. By, you know, quantifying the measures that they claimed showed inferiority of other people, which is self-evidently not true. And also, you know, just like I mentioned with, you know, the history of the Black community in the US, be very leery of medical researchers because of a history of abuse. Also, lots of folks are particularly leery of these sort of strains of research because of a history of abuse. So important to think about and be aware of those, you know, that historical milieu, I guess, and also how that's going to affect how folks feel today. Hey, old player, good to see you. Hopefully your electricity situation is getting better. Despite efforts over the past 20 years to increase the inclusion of underrepresented populations in datasets, as of 2019, Indigenous peoples still constituted less than 1% of genomic datasets, while contemporaneous sources estimated the Indigenous peoples accounted for about 7% of the global population. And here's the bit that is super, super relevant to us in linguistics and NLP. Cultural knowledge is in many cases considered sacred, and there are sustained concerns against infringements. Intentions of genetically modifying the kalo, taro plant in Hawaii, for instance, have been opposed because the plant is culturally recognized by Native Hawaiians as being an ancestor. Yeah, I don't think calling Hawaiians Americans is great. Apologies for that misspeak. These issues are further compounded for genomic data. The protection of these data is especially relevant to Indigenous communities as a result of experiences under colonialism, working with researchers from primarily white institutions. Sometimes you'll see that you know, shortened as PWI. Medical research carries a legacy of structural racism that has affected minority communities worldwide and has resulted in mistrust and skepticism. So, like I mentioned, the Tuskegee Valley experiments, you know, a history of white supremacy as the main research aim. Yeah, lots of reasons. Also, just like horrible things done to people in the name of quote-unquote science. For Indigenous groups, this has continued to be fueled by disrespect, unapproved secondary research, and broken promises. Misuse of Indigenous genomic data undermines sovereignty, with the inclusion of group identifiers such as tribal community names in genomic data, enabling commercial use by being misrecognized, commodified, and sold as ancestry tests. Oh, these ones. I got lots of feelings about them, and my recommendation to you as an individual is to absolutely not do it, and also strongly recommend to your genetic relations, should you know them, that they also not do it. Preventative measures such as removing identifying markers from genomic data are not reliable options because anonymized data could still be exploited to identify individuals and relatives. No way to get around that. That's just how genomic data is. And also, you know, perhaps not to the level of individual recognition, but also true of language data, right? All language data contains social information about the people who produce that language data, and that can include social group membership. Given this context, open access data policies are fundamentally not suitable for indigenous genomic data and may act as, quote, just another form of colonial dispossession. Ultimately, indigenous peoples should have control over and benefit from information generated from their communities, that includes language data, and decide for themselves whether to make their data openly accessible. Apologies for my dog. He thinks he's a big scary guard dog. All right, so basically, and the suggestion that they have given this, the fact that the precision medicine, should it come to being, could be very beneficial for these communities. The sort of general approach they're taking here is using federated learning instead, using data sets distributed across multiple devices or data centers. A partially trained model is distributed from a central server to independent nodes, which train the model on the data they have access to. So you can sort of think about, instead of parallelizing over GPUs, your epochs are part of the data set that's available to the specific, to the specific node that you're running on, and the parallelization is across the data subsets, as well as the sort of the runtime and weight updating. If that makes sense. I'm assuming y'all are mostly well-versed enough in machine learning that we don't need to go into too much detail about that. This is in contrast to open access models, as the independent nodes can contribute to training models without ever exposing their data. Oh, okay, yes, no, that all makes sense. I was like, wait, what's an open access method? Wouldn't that mean that they see all the data? Yes, so the sentence structure confused me. They're talking here about the federated learning, where the models, the training can occur without exposing the data. Now I will say, particularly for language data, particularly if you're using a large language model, we know memorization occurs. And yes, certainly it's not the aim of the model to memorize, but we know that it occurs. Again, I personally have not seen compelling evidence showing that it is not occurring in pretty much any large language model, architecture. So I don't know that this is a complete, I think this helps if the issue is the storing of the data. And also, if access to the model itself will be very limited, I don't know that this would actually be helpful in a situation where you're trying to occlude particular pieces of language data. So, but it's good for things like HIPAA and GDPR, and could address indigenous privacy concerns in genomics research. Again, if no memorization of the underlying data occurs, I think that's going to be a problem specifically for language data. So, interesting. I think, but we talk a lot on this channel about how I think, self-determination and community self-determination is very important to me. And I think that, indigenous communities should absolutely have sovereignty. An issue that we're having today in the United States, as the U.S. government is considering overturning important treaty acts. Anyway. So that's the general idea. The paper is, again, a comment in Nature Machine Learning, I think, and it was federated learning and indigenous genomic data sovereignty, which, again, I think very relevant in the natural language processing space. All right, next up, we have a paper. Sorry. So this paper is in Register and Social Media, which is a specific it's a special edition. Is that what it's called? Special edition? I think it's called a special edition of the journal Register Studies, edited by Isabel Clark and Jack Grieve. And the specific paper is "The Medium is Not the Message: Individual Level Register Variation in Blogs versus Tweets." So Register is... sometimes we talk about domain effects on the channel. Register is one of the things that can vary. And it is by Tatiana Scheffler, Leslie Ann Kern, and Hannah Seaman from universities in Germany. I'm not going to try. I apologize in advance. All right, yeah, so let's get in. So this is open access. And yeah, let's just hop in. Linguistic expressions in social media vary along many axes, including author style, the specific medium and its affordances, and others. So this is like, tweets are short because Twitter is character limited. In this paper, we argue that different registers must be distinguished within social media, and that registers should also be included as an important factor independent of social medium in analysis of variable linguistic phenomena. We introduce a new German cross-media corpus consisting of blog posts and tweets from the same 44 authors. Ooh, parallel data. You love to see it. I love to see it. I love parallel data. We define the registers as informative, narrative, and persuasive based on situational characteristics of the texts. We then correlate the registers with two variable linguistic phenomena, German modal and intensifying particles. So this is classic sociolinguistic study. We have a social variable, right? So there's actually two sets of social variables here. There is it a tweet or is it a social media post? Is it a blog post or is it a tweet? And then there's a second variable, which is what are the registers? Informative, I'm telling you something. Narrative, I'm telling you a story. And persuasive, I'm trying to convince you of something. And then, so those are the social factors. And then we also have the linguistic variables. So in sociolinguistic studies, usually you have a social variable, a linguistic variable. Here we have two linguistic variables, the German modal and intensifying particles. I don't know what the German modal is. Modal is a voice. I'm just going to quickly Google in another tab. I'm not using Google, but I believe it is a voice. Oh, I'm thinking of modal voicing. Yeah, so that's what I'm doing here, whereas this would be breathy voice, and this would be glottal voice. Let's see. Modal voice, yes. Is it a mood? Modal verbs. Okay, so I think it's just like a conjugation? Question mark? A modal is a verb that combines with another verb to indicate mood or tense. A modal, also known as a modal auxiliary or modal verb, expresses necessity, uncertainty, possibility. Oh, right, like double modals, like might, could, might, should, can, will, I guess. I don't know that I've ever heard anyone say can, will. Okay, yeah. Right, so there's specific types of words like can, should, will, have, etc. And intensifying just means like more, right? So best, better. Oh, let me find one that's actually regular. Hot, hotter, cold, colder. Hotter, hottest, colder, coldest are, intensifying morphemes in English. I have no idea what the German intensifying particles are. I don't speak German. In each case, we document considerable inter and intra individual variation in the expressions used and their frequency across texts. So both different people are doing different stuff and specific people are doing different things with these variables depending on question mark. I'm sure they'll talk about it. The statistical analysis showed that the register grouping corresponds more closely to the linguistic similarities between texts than the grouping by median does. Oh, okay. So I said there were two social variables, right? Is it a blog post? Is it a tweet? And then there's the three register variables, informative, narrative, persuasive. So what they're saying here is that we've been treating, this is pretty common, in NLP, we've been treating, blog posts and tweets as two very important distinctions that are going to be more like each other than they are. Right, two tweets are going to be more like each other than two blog posts is sort of the assumption. But what they're showing is based on the specific sociolinguistic variables that they are using, this German modal and intensifying particle, and the fact that they have matched texts for each of these authors, what they found is that actually the specific task that they're trying to achieve with the language, are they being informative, are they telling a story, or are they being persuasive, are the, the relevant things. So the, outcome kickback? That's not it. That's not the word. What's the word I'm looking for? Take out. No. The takeoff. Takeaway. Whew. Wow. I got there eventually. So the big takeaway here is that the thing that is more important is actually what's going on in the text than where the text was published, which I think, intuitively makes sense. Yeah, so I'm not planning to read any of these papers, word for word, but I think the things that are going to be most helpful are the defining register. I want to know about these linguistic markers, and then I think looking at the analysis, and there will be some pretty charts, I'm almost positive. So defining register. Are these links? They aren't. All right. That's the paper. I see it's an attachment. So this is an open access paper, and I didn't actually go and get the paper because I knew it was open access. Hold, please. The last one I had to get a copy from the author. Here we go. Okay. So we just need to go through the DOI. Fabulous. I did get the next one too. So let's start by defining register. The term register, reading here, defines the situational context of communication. Bieber and Conrad, 2005. Registers are thus primarily differentiated in non-linguistic terms, although linguistic variability can be observed when comparing different registers with each other. Contributing factors to register variation, amongst others, are situational characteristics such as the setting and channel of communication, discourse participants, their relationships, as well as the purpose of communication. Takeaway. Yeah, thank you, Iliam. There's a little bit of a lag between me and the stream. I think you got there before me. So basically things that they're saying, hey, you should think about this are the setting, right? So where are you using the language? Are you in a courtroom? Are you in a doctor's office? Are you on a YouTube channel? The channel, how is this information being transmitted? Are you face-to-face? Are you on the phone? Are you on Twitter? Discourse participants, who are you talking to? Are you talking to your family? Are you in private? Can people, discourse participants and their participants, right? And their relationships. Are you talking, to a stranger at a bus stop? Are you talking to, are you arguing with somebody on Twitter? Is it a friend that you know well? Is it someone you've just met? As well as the purpose of communication. Are you yelling at your neighbors for having their music too loud? Are you, testifying in court? Are you talking on a live stream? So all of those things will change the way that people, use language. So here's the linguistic variability can be observed with comparing different registers. But what makes a register specific is not the linguistic variation. The linguistic variation is caused by the difference in register, is sort of the point that they're making in this this section. Which may require certain linguistic features in order to be successful. Register variation in social media has been analyzed punctually. Analysis of stylistic variation in former US President Donald Trump's Twitter posts, or within a very broad analysis of online speech, namely as part of a multidimensional analysis in the content of social web in general. Bildhauer, Pankratz, and Schaefer, 2021, argue that it is impossible to determine universal registers in German and instead propose an exploratory method for defining registers in a data-driven way according to the occurrences of linguistic features in the corpus. So this is more like a clustering or an unsupervised learning task based on specific linguistic features that vary. For this study, we will not follow this approach since it may lead to circularity in argumentation. We want to investigate. Sorry. So the reason I said that was that this is this is a very polite way of saying that they think that the people they just cited are wrong. Right. So circularity in argumentation means that X is true because Y is true because X, which is not great scholarly, form, I guess. We want to investigate how linguistic phenomena such as intensifiers and particle vary across media and registers, which means that we cannot use these linguistic features to differentiate between registers in the first place. Instead, we must rely on the extralinguistic conditions within which utterances are made to define registers in our social media corpus. Okay, so they're saying specifically for them, if they tried to use this approach, it wouldn't work. They're not necessarily saying that the proposed approach is, unfit for purpose. They're saying it's unfit for this purpose. They're not necessarily saying you should never do it. But since they are sociolinguists, right, which means that they're going to be counting linguistic variables, I think for them, using the presence of linguistic variables to determine or potentially try and label the registers will never actually be that useful. All right, and let's quickly look at some of the tables and stuff. So the three registers that they're talking about are informative, narrative, and persuasive. So the purpose, and then they can be divided by purpose, topics, interactivity, reader involvement, and author involvement. So informative, passing on information, showing expertise, drawing attention to a topic, notifications, transfer of knowledge, announcements. Topics are milestones in personal life, competitions, reviews, recipes, nutrition, and crafting. Interactivity, low, rarely addresses the reader, no engagement, no call to action, no reaction needed or expected. Author involvement, low, rare use of I, me, personal position, not expressed, right? So it's just like, So I just remembered my my representative passed away last night, so that would be, sorry. That would be an example of something that is informative. Me just telling you that. I don't expect you to do anything about it. It's not a story. Narrative, reporting on everyday life and experiences, authenticity, relatability, sharing experiences, diary. I might also add ads in here, or ads that are trying not to be persuasive. Topics, everyday life, holidays, career, health, nutrition, personal life. Interactivity, optional, can be medium to high, depending on format or level of community. And the author involvement, medium to high, depending on the content and aspired level of relatability. And then finally, persuasive. Purpose, influencing readers, activism, politics, change, awareness, positioning, and promotion. Okay, so this would be ads. Topics, parenting, nutrition, product placement, politics, gender, education, and sustainability. And I'm sure that the topics in here are specifically for their data. They're not saying that these are the only topics or all the topics that occur with these particular registers. Interactivity and reader involvement, high, expected, might be provocative, direct address, high level of emotionalization. And author involvement, high, speaking from own point of view, position visible and distinctly expressed, use of I and me, arguments on a personal level. All right, and I have some sort of different discussions. And then the two linguistic markers that they're talking about. So the first are modal particles. We analyze the use of German modal particles and its interaction with medium register and intervariation. We define modal particles as non-inflected sentence modifiers that do not affect the truth conditions of a sentence, but are used to express the author's attitude towards the denoted preposition or make assumptions concerning shared knowledge, the so-called common ground, of author and reader. The meaning of modal particles is very difficult to describe and varies in different contexts. Most German modal particles do not have an exact match in other languages. Modal particles are generally assumed to be typical of speech, and their use varies greatly between individuals and linguistic modes. And then some citations to see. We therefore expect that the use of modal particles in our corpus will depend on the individual author, but also on the medium and register. Medium here being Twitter versus blogs. The most frequent modal particle in our corpus is ja, J-A. Probably ya. We try to translate ya in the following examples, keeping in mind that modal particles are in fact very hard to translate. The particle ya is often used to indicate known information. I'm gonna try it. I'm just gonna hop in there. So the German is Ich bin ja ein Einzelkind, Einzelkind, which is translated, as you know, I am an only child. Here, Ja-X is an expression of the assumed shared knowledge of speaker and hearer. The speaker is assuming the hearer knows that the speaker is an only child, but it can also be used to express surprise. Du hast ja ein Loch im Armel. Again, apologies to the German speakers out there. You may need, I don't know, earmuffs. Look, you have a hole in your sleeve. In example 2, ja is used to express a change in common ground because a new piece of information, the hearer's sleeve having a hole, is introduced in the common ground by the speaker. Wow. Did not know about this. Good to know, I suppose. For those of you who are German speakers, and if you want to provide a little bit more context, feel free. And then, sorry, intensifier. That was because I saw the Tagliamonte citation. I was like, Sally. Sociolinguistics is quite a small field, and I know most of these people. Maybe not most of them, quite a few of them. And I know about this paper in particular because I know Tatiana. For the second case study, we analyzed the use of intensifiers in our corpus. Intensifiers are words or expressions that can be used to boost or tone down the intensity of a gradable expression or utterance. So gradable, it has to have a form that is higher and lower. Like modal particles, intensifiers are typically used in speech rather than written language and in formal rather than formal language. A good example of an intensifier being used informally in a more formal setting is in the US, we have a show called Grown-ish, where ish is sort of it's an intensifier, but it reduces the intensity. Not usually something people would use productively in a formal setting. So part of what makes it sort of like an appealing and interesting title is that like, oh, that's, it's a novel word, but also that's sort of a mismatch. Usually the titles of shows tend to be pretty formal. What was I doing? Blah, 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 blah. Intensifiers show greater individual variation and are subject to rapid change. It has been shown that intensifiers can be frequent in written social media data as well. German intensifiers have not been studied in much detail as English ones. Cloudy, 2006, provides an overview of German intensifiers by their source semantics, and Brendel, 2007, discusses issues with the categorization of German intensifiers. Stratton, 2020, conducts a large-scale corpus study of intensifiers in spoken German, showing that they are used frequently. 37% of all intensifiable adjectives were in fact intensified. My God, that's very frequent. Sorry. Wow, that is, I don't know the stat off the top of my head for English, but I don't think I intensified almost 40% of my adjectives. Wow. And that the use of intensifiers varies by gender and age, confirming results from other languages. All right, let's scroll and see if we can find some cool graphs. Table. All right, so here we have register distribution within our social media corpus. So of the 390 blog posts, 13% were persuasive, 52% were narrative, and 33% were informative. Of the 44 tweets, 20% were informative, 45% were narrative, and 6% were persuasive. All right. And now we're looking at what's the counts here. Modal particles, absolute and relative. So for the blog posts, the overall about 8% had some sentences with modal particles. Persuasive sentences had the least, about 2%. Informative, the next most, about 5%. And then narrative, the next most, about 11%. And that pattern is not exactly the same in the tweets. So for the tweets, the informative tweets have the fewest modal particles, about 3%. And then the persuasive tweets, about 5%. And then the narrative tweets, about 6%. And about 5% of all tweets included these modal particles. Interesting. And over the entire corpus, it's about 6%. So it looks like tweets tend to have a little bit less, blog posts tend to have a little bit more. That's, okay, counts are relative to the total number of sentences in the registered medium. Great, I was gonna be like, but tweets are shorter. What about that? So they've been normalized by sentence count, which is good because it helps to control for the fact that you have some, what's the word I'm looking for here? It helps to control for the fact that you have disparities in length of the sample texts. Oh, sorry, something I didn't say is that for the tweets, they're also in between narrative informative, there's a narrative informative, and in between narrative and persuasive, there's a narrative persuasive, which has the narrative persuasive has the most modals of all of the tweets. Interesting. So we got a chi-square, that there is an effect of, because there's two variables, that looks like there is an effect of register. And then case study for the intensifiers, looking at the blog posts and tweets, it looks like there's 5 different people here in the 6 user subcorpus. No, sorry, this is the distribution of the specific intensifiers. So in the intensifier column, there is ser, S-E-H-R, gans, G-A-N-Z, gar, G-A-R, and worklich. I really don't speak German. W-I-R-K-L-I-C-H. Okay, so this is looking at which of these is occurring the most, and it looks like the pattern of incidents is pretty stable across the blogs and the tweets, with so being the most common. In both cases, no, in the blog posts, gans is the next most common, and then ser, S-E-H-R, those are flipped for the tweets, and then gar and then worklich for both of them. And then if we look at the counts, and I'm just gonna eyeball this, I'm not gonna keep reading tables aloud, absolutely riveting. Okay, so we're looking here. About 3% of the blog posts contain intensifiers, about 2% of the tweets do. And yeah, so it looks like for both of them, narratives have the most intensifiers, followed by persuasive, followed by informative. Yes, it looks like there is a dependency, again, based on this chi-squared, between register and intensifier count. Yeah, okay, and it looks like they broke it down by, so they're only using the most common of the intensifiers. That's so, oh, okay, great. And I was going to be like, okay, but then they're going to be doing, a lot of comparisons if they're only looking at one of the intensifiers. If they also looked at the other intensifiers, but it looks like they did do the Bonferroni correction, so that's good. Sorry, that's a bunch of stats. Y'all don't need to know about that if you don't already. Unless you're doing research, in which case you should. All right, yeah, so it looks like the... For the intensifiers, there was no effect of medium, and there was a strong effect of register. For the modal particles, like that it looks like there was an effect of both register and medium, and that the effect of medium was a little bit higher than the effect of register. So, yeah. So basically the point of this is that you can't assume that the medium is the register, and if you do, you are likely to be sort of muddying your results. So you would want to know about both the register and the medium, which means, both where was this language data produced, and also why, right? Why was this person creating this language data and sharing it out? And if you have access to both of those, you should be able to get, here they were looking at linguistic particles, but if you're thinking about this as sort of, if these things have a verifiable, quantifiable difference, right? Which, looking at this final table, it looks like, yeah, sure enough, there's a pretty statistically robust difference for this subset of folks. it looks like it's a little bit more robust for register than it is for medium. Then, if you're thinking about, hey, I'm putting together a text corpus, I want to sample it, or what should I sample from? Or I have a text corpus, I need to figure out, the distribution of groupings within it that are going to be relevant to my model output and, generalizability. If you have a model that has only been trained on, a single medium, that doesn't necessarily mean that there's not meaningful variation, or even a single speaker on a single medium. There's still going to be meaningful variation of token distribution within, subsamples, not subsamples, but subcategories within that sample. Does that make sense? Hopefully y'all are picking up what I'm putting down. The point that they're making is just looking at the medium is not going to be enough. You're also going to need to, consider what people are trying to say, which is also relevant if you're trying to do, prompt engineering. How are you going to get, and you want, let's say, you want to create narrative blog posts. Well, it's not enough to say just like, hey, I need a blog post. You also need to consider that you're going to have a more natural sounding blog post if you somehow get your prompt to include information about it being narrative in a way that is relevant to the particular speaker population. So that's the idea there. Interesting study. I learned about some German sociolinguistic variables, not something I know very much about. And also some, helpful citations for the thing I'm always saying about people don't use language in the same way everywhere all the time. Here are some ways in which they use language differently, along with, a nice, easy to understand, quantifiable difference. All right. Moving on. It's been an hour. And this is why I have decoupled the paper reading portion from the rest of the stream on Thursdays, because I am already tired, and I can't imagine trying to talk about all the news as well anymore. All right. Next up, we have a paper from Empirical Software Engineering 2023, accepted August 8th. So it must be forthcoming. An actual preprint? What? For those of you who are not aware, preprints are supposed to be, my paper has been accepted before it is published. Here is a version of it before it is published, but it's undergone peer review. Or at least historically, that's what they were. Certainly no longer. All right, so this is from Empirical Software Engineering, workflow analysis of data science code in public GitHub repositories. And it is by, I'm going to apologize first, Divya Bharati, Ramasamy, R-A-M-A-S-A-M-Y. I am sorry. Christina Sarasua, Alberto Baccelli, B-A-C-C-H-E-L-L-I, and Abraham Bernstein, and their affiliations are a secret? Sorry, I'm looking for the footnote for their affiliations. Well, mysterious, because for those of you who are watching, you can see that after each of their names, there's a little footnote 1. Usually that means that if you just look down a little bit, you'll find the author affiliations. Oh, what? They have a little bio with headshots at the end of the paper. I have never seen this before. Is this like a specific this journal thing? Okay, well, we've got little bios and headshots of all of the researchers at the end of the paper. So the first author, Ramasamy, again, apologize if I'm saying that incorrectly, PhD student at the Department of Informatics at the University of Zurich. The second author, Sarasua, postdoctoral researcher in the Department of Informatics, University of Zurich. Alberto Baccelli, associate professor of empirical software engineering at the Department of Informatics, Zurich, and Abraham Bernstein, full professor of informatics, as well as director of the Digital Society Initiative at Zurich. Okay, so everybody is from Zurich. I've never seen that before with like the glamour shots at the end of the, You know what? Honestly, when I was in grad school, that would have been hella helpful just to like see everybody who I was citing and be like, when I see you at a conference, I will know who you are. But I'm not going to conferences anymore. And I feel like it could potentially open up space for more unconscious bias than you would get just from the names of folks. I don't know. Anyway, I am perhaps obviously interested in this because I'm a nosy Nelly. I like to know what people are doing. And also empirical software engineering is a field that I find interesting and don't know that much about, but I've had to write code and also had to read a lot of other people's code. So I guess I have some sort of practical knowledge of it. All right, abstract. Despite the ubiquity of data science, side note here, I'm not entirely sure if they're going to talk about data science as just the analytics side or using the sort of thing that's kind of changing where data science means both, analytics and, business BI. Business I. Intelligence, probably intelligence. And also machine learning engineering, training and deploying systems, ML ops, all of that being under the umbrella of data science or not. Question mark. It's sort of changing. I get the sense that it might be changing more in the US than it is in other places. Even though the scientific literature has hinted at the iterative and explorative nature of data science coding, I like to call it the guess and test, we need further empirical evidence to understand this practice and its workflows in detail. Such understanding is critical to recognize the needs of data scientists and, for instance, inform tooling support. Now, this is something that I am interested in as someone who has a background in developer advocacy, where part of what you do is you're like, I'm an expert user of this tool. Here's my feedback. I talk to a lot of expert users of this tool. I have synthesized their feedback. Here it is, product manager. This is the thing that's a problem for people. And sometimes folks listen and sometimes they don't, but that's, if you are a developer advocate, for any of you out there, your job is, I'm trying to remember the exact quote and source. I don't. Anyway, the quote is something like, your job is not to make people understand, your job is to have told them. Or not like to change their behavior or make them agree, but just like to have told them. And if you did that, fine. To obtain a deeper understanding of the iterative and explorative nature of data science coding, we analyze 470 Jupyter notebooks publicly available in GitHub repositories. We focus on the extent to which data scientists transition between different types of data science activities or steps, such as pre-processing and modeling, as well as the frequency and co-occurrence of such transitions. Now, I will say, as someone who works in Jupyter notebooks, without an edit history, I don't know that you're going to get the whole picture there, because I certainly don't start at the top and work my way down and then hit print and be like, I'm done. I definitely do a little bit of bouncing back and forth, redoing earlier steps, changing things, seeing what happens, etc. For our analysis, we developed a data set with the help of 5 data science experts who manually annotated the data science steps of each code cell within the aforementioned 470 notebooks, using the first order Markov chain model. Oh, it's been a while since I've read a paper with Markov chains. Not that there's anything wrong with them. I'm a big fan of Markov chains. They're just not du mode? Is that the French for like being fashionable? Du monde? They're not fashionable. A la mode? In the US, that means when you say pie a la mode, you mean specifically with ice cream, but I think that means like in the fashionable way. I don't remember the French term I'm looking for. Come to my streams where you can get lexical access errors in multiple languages. All right. In addition to providing deeper insights into the implementation practices of data science coding, our results provide evidence that the steps in a data science workflow are indeed iterative and reveal specific patterns. We also evaluated the use of annotated data sets to train machine learning classifiers to predict the data science steps of a given code cell. Oh, that's fun. That could be really helpful for a product, right? Clippy for data science, right? You're like, janitor : in R, and you get a little pop-up that's like, I see that you're trying to do some data cleaning, or you you're importing TQDM in Python, and they're like, I see that you might be training some models, that sort of thing. We investigate the representativeness of the classification by comparing the workflow analysis as applied to A, the predicted data set, and B, the data set labeled by experts, finding an F1 score of about 71% for the 10-class data science step prediction problem. That's not bad. That's a lot of classes. Interesting. All right. So again, I'm not going to read this. It's 47 pages. I'm not going to read the whole thing word for word. Process of deriving insights from data. Attention. Okay, so I think it's probably going to be a little bit more analysis focused, particularly because they're only using Jupyter notebooks, which means they're probably not going to be looking at a whole bunch of production stuff. Well, I guess Netflix uses Jupyter in production, but mostly I think when people take things to production, they tend to take it out of Jupyter. A set of studies cited here suggest that a data science workflow is composed of multiple steps: data acquisition and preparation, pre-processing, feature engineering, modeling, visualization, and deployment. Yep, that sounds about right to me. Okay, some other empirical software engineering studies on various workflows and GUIs. Data scientists generally prefer GUIs and need tools similar to IDEs. Similar to an IDE. For example, in a traditional IDE, annotations have proven to be effective in aiding navigation and understandability. I definitely use this in RStudio. Which, I mean, if they're looking at Jupyter notebooks, they're not going to know about the RStudio folks, because mostly if you're working in RStudio, you're probably going to be using Markdown notebooks, or like Bookdown or something like that, rather than Jupyter. Even though the R in Jupyter does stand for R, and the J stands for Julia, I think they tend to mostly be in Python. All right. Yeah, so a bunch of citations. This is so for those of you working in NLP, perhaps, look at the density of citations in this introduction. Look at them. So on this first page, there's probably like, I don't know, 20, 30, maybe 40 different citations. This is common in most other fields. It is, hey, hello, Potato Fire. It is wild that in machine learning and NLP, you'll have like 10 total citations in a paper. Very, very irregular. Let me put it that way. Granted, they do have 47 pages to work with. They've got a lot more room, but also scholarship, certainly in my training, is about depth and interconnectedness with the literature and understanding how your work fits within the work that's already been done. Because otherwise, you're not doing scholarship, right? You're doing something, right? Like, I'm not saying that what you're doing is not necessarily useful or helpful, but what it is not is traditional research, which involves, integrating with a research community. It is a social practice. All right, introduction. Oh, that's a lot of citations. For those of you who are interested, I think this is going to be a real treat if you are not familiar with this literature to dig into. All right, so the main contributions, they have a novel publicly available data set, Das Wow, to support data workflow analysis and report a set of descriptive statistics related to code cells, variables, functions, lines of code, and lines of comment for the data set. So remember that this has been hand annotated by data scientists, so potentially very useful. New empirical insights on data science workflows. All right, here's the meat. The meat here meaning the central, important, and weighty thing of it, not necessarily like actual meat. We find that I think that actually comes from like not necessarily specifically eating animals, but like more butchering, I guess. I'm spending too much time on this metaphor, sorry. We find that 29.75% of the code cells are written to explore the data based on the primary purpose of the cell. That is lower than I would think. Well, actually, that's just exploring, right? That's just looking at the data and figuring out what's there. In line with common knowledge, we also find that 23% of the code cells created by data science pre-process this data. Okay, so this is data cleaning. So we got about a third of things are just looking at stuff. About a quarter of things are doing data science. Moreover, 24% of the code cells in Jupyter notebooks implemented more than one type of data science activity, thus indicating that 1, the overlapping nature of data science activities, and 2, data scientists not using Jupyter's cell structure to logically separate the data science activities. The shade. Listen, if you're interested in logically separating stuff to create, ergonomic workflows, Jupyter is probably not going to be your main tool of choice. I'm just going to put that out there. Jupyter is for people who are poking around and, experimenting. Oh, I don't know that they meant that quite as severely as I am reading it tonally. I just think it's very funny. Our workflow analysis also shows the data science is iterative throughout and at every step of the workflow. And like I mentioned, I think they're probably undersampling that iteration because they're just looking at completed notebooks, and are not necessarily looking at like a timeline of edits of the notebooks, which I think generally tend to have a lot more, what's the word I'm looking for? Back and forthing, up and downing, jumping around. Evidence that Das Wow can be extended with the help of existing supervised classification methods. For this, we employ and evaluate single label and multi-label classification methods because, what was it, a third? 24% had more than one activity, right? Can you imagine how nice this would be in a tool though, right? Like I'm writing my Jupyter notebook. I'm like, okay, I'm done for the day. I come back the next day. Suddenly every cell, little color coded sidebar that tells me what I was doing in there. Ooh. Maybe, code completion suggestions based on a specific type of, the cell that's been annotated. I look at somebody else's notebook. Oh, these are all cleaning. Oh, these are all data exploration. Like, obviously you can do that with their eyeballs, but if you're like, where did you train your model? Scroll. Oh, it's the pink cell, right? That sounds good. I would like that. That sounds like a fabulous addition to a tool. We show that a multi-label random forest classifier performs better in terms of F1 score with features composed of lines of code and additional software metric information. We also discuss factors that may impact the performance of the classifier. Furthermore, we repeat the workflow analysis on the predicted data set and show the representativeness of the classification. So they're not really worried about the class imbalance problems because it looks like they handled them pretty well. Doesn't that sound nice though? Yeah, I think it does. I'm imagining this wonderful tool. All right, so background again. Look at this. Look how closely this is tied into this citation network. I look at the date range too. The earliest is 1997, and the most recent is 2021. Now, I will say I'm not super knowledgeable about this particular research area. I cannot tell you how good the citation network is, but just like that's a lot of richness, even if some of the citations are bad. Like if you only started with this paper, you would have a good understanding of where else to go in the field. If you started with like one ACL paper, good luck. You'll be like, the Viswani paper. Well, this was a dead end. Anyway. Yeah. Classification of source codes. This is the thing that I think just sounds like the most cool. Methods for classifying source code for various purposes. Identification of programming language. Authorship. I've never considered author ID on code. Duh, of course you can do that. Duh, of course that would be helpful. Oh, that's Mark's code. He was an intern who left a year ago. So you're not going to get more information than that. Or like, oh, that's, Pooja's code. She's in, Tokyo. You're going to have to wait to talk to her later in this evening. Or you can send her an email or something. Makes sense. Topic and quality have been studied extensively in the field of software engineering, particularly machine learning techniques, blah, 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 Maxent, SVMs, decision trees, k-nearest neighbors, naive Bayes. Is random forest not like a usual thing here? Interesting. I think that's probably what I would use in this particular case. Several features including code metrics, lexical tokens, code header file names, comments, readme, etc., represented in terms of n-grams or phrases, syntactical structures, and coding style have been investigated in source code classification problems. Syntactical structures, here I assume, probably way easier to do with code actually, because you can just get the ASTs. You don't have to, the parsing is baked in. You do not have to do the natural language parsing to create the syntactical structures for that. Although I suppose in the documentation part you do. Interesting. In terms of research on the classification of data science step in the source code, specifically based on workflow information, Zhang et al. Proposed weakly supervised transformer-based architecture to classify and assign source code to high-level data analysis. Okay, that makes sense. I'm looking at these dates for the citations. Yes, that also makes sense. Okay, so it looks like the work on this particular field does tend to be keeping up with machine learning and NLP as a whole in terms of what tools people are most likely to reach for. Yeah, okay, so they got their labeled data. How did they get the notebook? Retrieved from GitHub by the Design Lab team at UC San Diego. Okay, so it's a corpus of 1 million Jupyter notebooks in 2018. So this is gonna be a little bit of an aged sample. Oh, here's the question I had. Python accounts for 96%, although 1% were in Julia and 1% were in R. And they also had a large number of purposes, data science tasks, homework submissions, very common, and software development. So the purpose is the notebook was developed for data science tasks. So they're excluding student work here, which is important. Nothing wrong with students. They're just learning how to do it. So if you're trying to, you know, figure out what people are doing in the field, you're going to want the people in the field, not necessarily the students, because they'll get there, but you don't want to train a model on people who are themselves in training unless you're trying to do it for a teaching tool. And they only looked at Python, which makes sense given the small amount of R and Julia. All right. They focused on code cells, which makes sense. They had a bunch of annotation labels. So labels were helper function, load data, data preprocessing, data exploration, modeling, evaluation, prediction, result visualization, save results, and comment only. Lines of comment, including commented code. Wait, is this by line? I thought it was by cell. I'm just reading here to see if I can find it. Yes, okay. We also encountered code cells that contain only comments. All right. So it is by cell. Interesting. And then they're sort of comparing it to other, excuse me, they're comparing it to other general classifications. Interesting. And then annotator agreement. So it looks like they had 3 annotators. Very high agreement. So usually, particularly for challenging tasks, you'd expect IRR to be, inter-rater reliability is that IRR instead of annotator agreement. It's a little bit more of a linguistic-y way of saying it. But it looks like overall pretty high. So for most of these. Yeah, so it looks like it's a little bit low for save results across both sets of annotators and also data pre-processing, but pretty high for most of the other. E1 versus E3 for helper functions is a little bit low, and E1 versus E3 for result visualizations is also a little bit low. But like I would say, like, yeah, 50 to 60% is pretty good. And it's a 10-way classification, right? So like above 0.2 is above chance. Above 0.1 is above chance? Excuse me? Good job doing math. All right. And then for the second task, yeah. Oh, here actually they say 0.4 to 0.6 is fair. 0.2 to 0.4 is poor. No, wait, sorry. 0.4 to 0.6 is moderate. Okay, so here we have 2 additional annotators, E4 and E5. Actually, it looks like overall the agreement is higher on this second round. except for E1 versus E4 for data preprocessing and E1 versus E5 for save results, which were the same two here. Yeah, save results and data preprocessing seem to be the most challenging to correctly annotate. Most of the cells contain between 1 and 5 lines of code. About 6% contained more than 20, so they tend to be pretty short, which is great. That's what you want, right? If you have a huge block of code in a Jupyter notebook, you should probably actually be writing a script. All right, more things, and then looking at the number of code cells and the percentage of code cells in the database. Number 1, data exploration. Number 2, data processing. Modeling was about 16%. Helper functions was about 8%. Good to see. Good helper functions are very important. Load data was also about 8%. Interesting. And then save results. Perhaps obviously the rarest at about 1%. Yeah, and then if we look at, so that's when you just look at the primary label for each cell, but again, it's a multi-label problem. So when you look at all labels for all of the cells, the same pattern emerges. It just gets a little bit more skewed. So interesting. Yeah. Okay, so this modeling versus non-modeling. Modeling tasks perform data modeling and in many cases focus on predicting future outcomes. Non-modeling tasks do not model data and are instead focused on processing, exploring, or analyzing data. Okay, so when I mentioned the sort of the difference between what I'd call maybe more of a machine learning engineer and what I call maybe more of an analytics, it looks like they are just making that distinction between modeling and non-modeling. And the biggest difference here is that if you are modeling, you have cells that include modeling. If you aren't, you don't. And that a lot of the, that bulk of the missing cells goes to primarily data exploration, also data preprocessing, and then also loading data. So it looks like if you are not modeling, you're more likely to perhaps be adding more different types of data and also doing more data exploration and preprocessing. So you maybe have been given something challenging to look at, which yeah, that fits with my experience. Yeah, various co-occurrences. All right, and then they've got, okay, so this is where they've got the Markov model, Markov chain rather. So what they have is that they have represented the tasks as nodes. Yes, with transitions between tasks being the edges. And then they're creating a Markov chain to show that. Do they have a... Yes, they do. Fabulous. I was going to say, do they have a little visualization of where people tend to go from where they do? They got like a little waterfall graph of the transition probability matrix. So stopping, most people come to stop after saving results, and some of them stop after comment only, perhaps a to-do list or things that they're going to talk about later. Save results and comment only tends to go into itself. So if someone has a comment only cell, they're likely to have another comment only cell after it, which may be because they're commenting out code potentially. Start primarily goes into helper functions. You'll love to see it. Great best practice. And for the rest of them, there's not a huge number of other very thick transitional probabilities. From data preprocessing to data exploration is pretty thick. From data exploration to itself, also pretty thick. From evaluation to modeling, pretty thick. From modeling to evaluation, much thinner, weirdly. And it looks like the sort of general pattern of steps in order based on, again, the transitional probabilities are starting, writing helper functions, loading data, data exploration, data preprocessing, modeling, evaluation, prediction, and then result visualization. So this is really cool, really great visualization, really good summary of what they found in their data. I'm a fan. Also, the end of the notebook only came after result visualization, evaluation, a comment only, code cell, or saving results. It's pretty interesting, right? Like no one's doing data exploration and then immediately stopping the notebook and then publishing it. Yeah. what is this? Distribution of number of lines of code. Oh, so this is how long each of the cells are. Results visualization and modeling tend to be the longest. That makes sense that results visualization tends to be pretty long. Visualizing in Python is a bit of a bear. I know there's lots of libraries, there's just none that are as nice as the ones that I like in R, to my tastes. Loading data also tends to take quite a bit. And then the one with the greatest variation is data pre-processing in number of lines of code. Yeah. We find that in our data set, about 50% of notebooks have at least one line of code cloned in them. Of the notebooks that have clones, 8 or more lines of code are cloned on average per notebook, and about 26% of the notebooks have clones higher than average. Yeah, sometimes you don't go back and clean that up, right? Yeah. Wow, this is a really, really rich paper. And I do want to talk about other stuff, but fabulous, very rich paper. They're talking about their classification accuracy. Again, potentially could be a very interesting product offering for folks working with data science. Looks like data preprocessing and evaluation tend to be misclassified as each other, which is pretty interesting. Probably because evaluation often involves loading in data and then transforming it to match the data you trained on. Yeah. Really interesting paper, obviously very long, very, very rich. Lots of, lots to learn here. And then the workflow analysis I think is very interesting. So yeah, if you teach data scientists, if you are a data scientist, if you work on tooling for data scientists, and that's both, machine learning engineers and also analytics folks, I think this is a particularly interesting approach. And also something where I might, oh wow, they've got a very detailed, in the appendix discussion of how to annotate the notebooks. Might be something you might want to, look into more. Some of this is sideways. Yeah, really good paper. Lots to learn. All right, next up is a citation, not a citation, an abstract. So this is in NLP and computer science. The conference publications are sort of the fancy ones and are usually archival, right? That means what you present at the conference is your finished work. In a lot of other fields, particularly linguistics, conference presentations are generally non-archival and generally represent, work in progress. Here's what I'm working on, and are intended to get like feedback from the audience and your peers. Some water. This is one of those, but Dong is one of my absolute favorite researchers. Dong Nguyen. Where's she at now? She was at the Turing Institute for a bit. It looks like she might be at the Brussels Center for Language Study, perhaps. And this is a you know what? I'm going to look it up so I'm not giving you the wrong affiliation. It looks like Laura Rossiel is the first author. It looks like she's there, but I want to make sure that I'm not giving you the wrong. Oh, apparently it's also the name of the Flappy Bird designer. That's not who this is. She's an NLP researcher. Oh, she's an assistant professor at Utrecht. She is absolutely fabulous. I love her work. What can I say? Big fan of her work. Yeah, she was at Turing. Here, I'm just going to pop this in another thing so we can talk about it really quickly. And this is her website. It's donguyen.nl. Yes, assistant professor at Utrecht, previously at Alan Turing and Edinburgh. She did her PhD at the University of Twente, TWENTE, master's from Carnegie Mellon, and has done a bunch of internships. Yeah, and does really, really good work, particularly in the field of computational sociolinguistics, which is a field that I worked in when I was in grad school. Kohaki says, I have to ask, where do you find these interesting papers? So good. So many places. Some of them I, get notifications about, because I follow a bunch of people on Google Scholar. So that's why I found about this one. Some of them I hear about because people talk about them online, and I happen to see it. So people who are sort of in my social network, previously Twitter, right now mostly Mastodon actually is where I'm finding a lot of these. Yeah. I'll also go through proceedings of like a big conference. Like I know it's NeurIPS right now, but I don't care about most of the NeurIPS papers, so I was just not going to do that. But that's also another way, and also just sort of being right. I mentioned that scholarly activity and research is a social activity. So once you're fairly embedded in a social network and a network of papers that tend to cite each other, and you're sort of keeping up on things, you get to the point where you can sort of find out about new things that are related to your interests. But yeah, it's very sort of organic. Twitter feeds, yeah, I find some stuff on Twitter. Less than I used to. Well, let me put it that way. That's happened pretty precipitously that it's changed. But this one I think I found out about because I get a notification every time Dong publishes something. And this is a paper from Laura Rosseel, Rosseel. Ross and eel are both words that I know how to pronounce, and I'm just going to assume it's two of them together. When small data meets big data, a study on socially meaningful spelling variation in English. So spelling variation is one of the things I was really interested in grad school, which is why this paper made my little ears perk up. And again, it has not been published, right? It was at the Sociolinguistics symposium in Belgium, but it is non-archival. It's just a, discussion about what they talked about. So in social media, spelling variation is abundant. Critically, many non-conventional spellings are not misspellings. By deviating from conventional spelling norms, writers create social meaning. Do not just correct all the spellings. You will lose information. Similarly, don't just remove punctuation. You'll lose information. This is a soapbox I get on all the time. Every time you transform the text input that you have, you lose information. And sometimes that information is, there's Mojibaki in here, right? Maybe that's information you do want to lose, but maybe it's not. And maybe it's something meaningful and that your system could use to better do whatever task it's trying to do. Misspellings are not, something you want to completely remove. For example, certain spelling may be used to invoke intimacy or to index a certain region. Various studies have analyzed patterns and functions of spelling variation, e.g. in Twitter. Oh, that's me. That was my NWave paper, I think. Oh, wait. Oh my gosh, wow. No, this was my working paper, the Linguistics Circle, the University of Victoria paper from a minute ago. Don't read that paper. I did better work after that. Yet, there has been little quantitative research on the social meaning of spelling variants. This study aims to contribute to tackling this descriptive lacuna. The lacuna is a hidden spot in sociolinguistic research on language variation. It's such an interesting topic. I wish more people worked on it. We do so by comparing the social meanings of spelling variants elicited through human experiments to do data-driven meaning representations automatically learned from a large corpora. As such, our study supplements its descriptive research aim with a methodological one. To what extent can traditional sociolinguistic small data, in quotes, and recent NLP-based big data, in quotes, approaches complement each other? God, this is catnip for me. I wish I could see this talk. I want to see this talk. We focus on spelling variation on the popular online platform Twitter, RIP. For those of you who are currently doing research on Twitter and are sort of like looking around being like, I feel you. I did research on Vine. Well, it was active. For those of you who are not familiar, Vine was a short-form video social media site, sort of similar to TikTok, much less spyware-y, that stopped existing. Well, I was actively doing research on it, so obviously a problem for me. I think I did a blog post with my results. I don't think I actually got them published because I was sort of like, well, I can't really get more data. We look at two types of spelling variation phenomena in English. One, spelling variation representing phonetic variation, e.g. workin versus working. So in American English, sometimes that final angama, as in working, can be said workin, especially informally. It's something that I do very commonly and don't really think about. Other examples of spelling variation that shows phonetic variation would be something I used in the title of my paper. Here, go on, AWN, here being a representation of on with the open O vowel, so on as opposed to on. On, that second one sounds, I don't know. I have the open O there, on. I know a lot of people don't, and it sounds to me a little bit like on. Maybe a little bit more Californian, maybe even a little bit Canadian, potentially. And two, spelling variation restricted to the orthographic level, e.g. swapping of characters. And potentially here, I might include things like spelling small, S-M-O-L, small. I don't know if that also tends to be a reflection of a difference in, I don't know if that's also a reflection of a difference in pronunciation, but it's certainly a stylistic difference that to me indexes, you know, specifically a topic, right? Talking about animals, talking about things that are cute. Is there, I vaguely want to say there's like markers like that in Japanese, that like this thing is, you know, an animal or cute. It's not just a diminutive, right? But it is like put in the class of things that are, you know, small. I don't know. Yeah. First, the social meaning of linguistic variance is measured in a written version of a speaker evaluation paradigm. Using crowdsourcing, we collect various social traits that are potentially associated with the social meaning of the targeted linguistic variation. Second, we compare measurements of social meaning with word embeddings, i.e. automatically learned mappings from words to high-dimensional vectors based on co-occurrences in the corpora. Our study brings novel insights into the social meaning of spelling variance and also draws attentions to limitations and opportunities of data-driven meaning representation for sociolinguistic research on language variation. Paper win! Give me the paper, I want to read the paper. It's not out yet. It's, you know, it was at the symposium. We'll get it eventually. I want it. Anyway, keep an eye out for it. I certainly will be. Please, 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 I want the study. That was the abstract I finished, I promised. And finally, we have this paper, in quotes. So this is, I mentioned sort of earlier the differences between a preprint, an actual preprint, and a sort of quote preprint. And this is definitely in the quote preprint. I might call this a white paper, right? So it's research released by a company, usually to further the aims of that company. And it's something a lot of the machine learning research these days is what historically people would have called gray literature. So gray literature is this idea of white paper is gray literature. Let's see. Here is a definition from the library at Monash University. Gray literature is information produced on all levels of government, academics, business, and industry in electronic and print formats not controlled by commercial publishing, i.e. where publishing is not the primary activity of the producing body, right? So I'm not that familiar with Epoch/Epic AI. I'm pretty sure they are not a publisher of scientific research. Yes, but I thought this was interesting for a number of reasons. So this is on the Epoch/Epic, epoch.ai.org blog. Actually, I should double check that. We're a team of researchers investigating and forecasting the development of advanced AI, a fiscal sponsorship of the project of Rethink Priorities. Epoch is funded through a grant from Open Philanthropy. This smells like effective altruism, folks. Rethink priorities. Mission is to generate the most significant possible impact for others in the present and long-term future. Using evidence and reason, we identify where resources would be most helpful and help direct them. We do this by conducting critical research to inform policymakers and philanthropists, and by guiding the development of new organizations to address key problems. Our work covers important and neglected cause areas, including animal welfare, artificial intelligence, notably neglected in terms of funding. The laughing there is because artificial intelligence as a field has many orders of magnitudes more funding than any other field I've ever been a part of. Climate change, okay, I would agree. Global health and development, and other work to safeguard a flourishing long-term future. We also aim to understand and support effective altruism. Yep, there it is. A community of people focused on these issues. Okay, so these are EA folks. Which is important framing, right? These are people who are getting money from philanthropists who are mostly tech workers who are, you know, interested in feeling like the thing that they happen to be interested in is also coincidentally just the most important thing that humanity should be working on. I'm very skeptical of effective altruism as a community. And nothing I have learned has changed that skepticism. Anyway. So that's where this comes in. And I was interested in this because I saw some very like, what's the word I'm looking for here? Wide-eyed reporting about the, you know, about this particular research project, which I will say, to my knowledge, has not been peer reviewed, right? This is on a blog of a website that is funded by, you know, quote, philanthropists for, you know, their idea of a long-term future that includes artificial intelligence, and where the well-being of, from my understanding, the well-being of those potential artificial intelligences is more important than the, you know, well-being of humans alive today, which is a stance that I personally cannot get behind. But it is by, it was published October 10th, I should say, so you have some context on the date, and the title is Will we run out of machine learning data? Evidence from projecting dataset size trends. Right, so it's looking at the recent history of the field, how much data we are using, and trying to figure out if/when we will, quote, run out of data. I'll talk about that in a second, but let's first talk about some of these authors. So the authors are Pablo Villalobos, Jamie Sevilla, Leonard, L-E-N-N-R-T, Heim, Tamay, Besiroglu, Besirogul, Marius Hobhan, Hobbhahn, and Anson, Anson, Ho. I don't know if you can see, one sec, can you see the little, yeah, okay, you can see the little, those of you who are watching and not listening, you can see the little images as I mouse over it. 1, 2, 3, 4, 5, 6 authors, all of whom, you know, I do not know as people, but just sort of looking at their little images, none of them seem to be femme. All right. Based on our previous analysis of trends in dataset size, we project the growth of dataset size in the language and vision domains. We explore the limits of this trend by estimating the total stock of available unlabeled data over the next decades. So the first thing I want to bring up is the premise. The premise here, right? Which is that a machine learning model is an end in and of itself, and the importance of the data is to improve the model. I don't know if they would necessarily agree with that characterization, but the way that this is framed seems to assume, like, takes that as inevitable, right? And for me, as someone who is interested in, you know, language technology and other people, as we mentioned on the channel, this is a wild claim to make, right? And also, again, as someone who has a background in statistics, what? What? If your causal model, has exhausted the population and you're like, well, I'm still uncertain, it's because the thing you're trying to model is uncertain, right? It's not because you need to create more humans so that you can study them, so that you can have more data, so that your model can be better. Why must you change the world or assume that the existence of the world is for the purpose of creating training data to train models? Like, I am not talking about utilitarianism and ethics here, but like my approach to data science and machine learning and NLP is I have problems I need to solve. These are tools that help me solve them. I will use, whatever tools that are available to me that meet my needs and are accessible. And I don't care about the tools as long as they work, right? Like, I need to know when each tool will work where, but like, I am not a tool maker. I am a person who is trying to solve problems in this realm. And the outcome is that the problem is solved and not that I have the tool now, right? And it's something that I've seen a lot with students as well recently, right? So they'll be working on a project, they'll have a data set, and the data set will be the population, right? They will have, they're working on a small population. They have information on every person in that population. They're like, well, the problem is I don't have enough data. No, that's not the problem. The data is a representation of the world, right? You have all the information that is available. I'm making a lot of faces here. You can't see them, but believe me that I am making them. You have information to everything that is available. Your challenge as a researcher, as a scientist, as a person who is solving problems is to take that and solve the problem. If the model that you're using doesn't work, you're using the wrong model. If the approach that you're using doesn't work, you're using the wrong approach, right? The point is not to change the world so that your job as a data scientist is easier. That is a wild thing to claim. Your job is to approach the world as it is and to solve the problem that you're trying to solve. This is such a deeply short-sighted, let me put it that way. So, that's not fair. It's a little bit ableist, right? To say that, particularly as someone who has a little bit short-sighted myself. Very short-sighted, actually. That's why I wear glasses. But this is such a buck wild. It is a buck wild thing to stand in your discipline and be like, my discipline can't solve the problem. The problem's the problem. The problem is not my discipline, right? So this idea is, that, hey, the issue is that we will, quote, have exhausted the stock of low quality language data by 2030 to 2050, high quality language data before 2026, and vision data by 2030 to 2060. This might slow down ML progress. I don't give a rat's butt. I don't care. How is this helping the world, right? Like, if your approach is no longer working and you have access to literally all the data it is, your approach is the problem, right? You need to be a better engineer. You need to be able to work with data scarcity. You need to be able to work with energy scarcity, right? Like the funding body here says that one of the things that they care about is climate change. And yet, I mean, to be fair, they are funded by a funding body. They do not represent the views of the funding body. But there's this assumption of like infinite linear growth that is, what natural process works like that? Literally none of them. Ugh. What a wild way to view the world. What a wild way to... This is a fake problem. This is not a real problem. Okay, I feel better. Anyway, I don't think I even want to go in it, right? Like, this is what they're saying is like, we have found that we're going to run out of data. What? That's wild. There are things that we are genuinely gonna run out of, and it's like time to address climate change, fossil fuels, right? Those are things where lacking the resource is the problem itself. But what? What? If you have all the data, there just is no more data. That is not the issue. The issue is that you are not being parsimonious. You are not being efficient. The methods that you have developed are too data hungry, and you need new, better methods. End of rant. All right. right, so that's been streamed today. Oh, sorry, again, what a wild worldview. What a completely wild worldview. And I know I've had a lot of scientific training. I am an empiricist by proclivity and also training, but wow. Anyway, yeah. So that is everything that we have for today. And just as a FYI, for those of you who decide to support the research papers, please, because it's an annotated bibliography, it'll always go up after stream. The news may or may not come up before stream. And if you get the links, please, you get both of those links every time. Both of those posts every time, because I need to figure out what the annotations should be during stream, right? So that is stream. Speaking of my monthly supporters, I just want to say thank you all very much. I appreciate you very much. You make it happen. And especially, I think Lisa is still my newest supporter at the moment. So thank you, Lisa. I appreciate you. I, of course, appreciate everyone watching as well, but I do appreciate my monthly supporters just a little bit more. All right, thank you so much for joining today, everyone. We'll be back on Tuesday for news. I'll probably have the face cam back. Hopefully. I hope I sleep well Wednesday. I'm having little dog problems that are making it challenging. So thank you very much for joining today, everyone. I hope this was informative. You learned something. I really want that paper, the small data paper. I'm very intrigued by it. And hopefully we'll be able to talk about it in a future research stream. Yeah, and I will talk to you on Thursday. I'll see you then. Have a great day. Stay safe, stay healthy, and I will talk to you soon. Bye.